All right, welcome to our second lesson in chapter one. This is lesson 1.2 called adding integers. We're going to look at some different integer rules, different models we can use to add them, and some different pairings that have specific names when it comes to math class. So let's jump right in. First of all, our learning targets, by the end of the lesson, we will be able to find sums of integers. Okay, some different building blocks that we're going to take to get there would be explaining how to model addition on a number line. We're also going to look at another way as well. We can find sums of integers by reasoning about absolute values. So looking at a number line and thinking about if their distances doesn't make sense. And then I can explain why the sum of a number and its opposite is zero. All right. First of all, our first method that we're going to look at is something called an integer counter, otherwise known sometimes as like algebra styles. All right. So in this situation right now, I'm modeling this equation, -3 plus 2. All right. I have 3 negatives right here, and I'm adding in 2 positives to the situation. Okay. What we're going to do is we're going to take each one of these and we're going to give it a value. So if I ever see a plus, I'm going to think of it as 1. Now, I ever see a minus, I'm going to think of it as a -1 or a -1. Okay. What's nice about having these different visuals is we can actually use them to kind of either cross out or help us figure out what is our final answer. Okay. If I can ever take a plus and a minus, right, we can kind of think of these as canceling each other out. Why? Well, because 1 minus 1 is 0 or no value. So I'm going to cross out every single 0 pair I have, and we'll talk about that more later. Okay, I see a minus and a plus right here. And what does that leave me with? Well, it simply leaves me with 1 negative. Okay, so to summarize that, if I were to add -3 and 2 together, my answer is going to be just that, -1. All right, so here are some examples that we might see come up that we can use these integer counters with. We will work a lot more in class with them, but just to model some of these, this is what it might look like. If I had -5 plus 8, I'm going to write 1, 2, 3, 4, 5 negatives. And then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 positives. And again, just like last time, we're going to go through and cross out all of our pairs that cancel each other out. So there's 1, 2, 3, 4, 5, and left over are 3 positives. So I would say -5 plus 8 is +3. For -6 and -3, right? I have 3 negatives to start, and then I'm adding 6 more negatives. Well, instead of crossing out this time, right, I can only cross out a negative and a positive. I have all negatives. So I'm just going to count up how many negatives there are. There's a total of 9 of them, and make sure that we write -9. For 4 plus -6, 4 positives, 6 negatives. Crossing out, I get 1, 2, 3, 4, and I'm simply left with 2 negatives. So this is one way using integer counters that we can kind of go about solving these problems. They're really nice, really tangible. You can look at them to work with. Okay, we're going to look at another example here in a second. So a couple keywords for you. This one is a quick reminder from last lesson. An integer, remember, is just a positive or negative whole number. Okay, so again, we have like 2, -41, 99, all of those. Okay, again, no decimals, no fractions, positive or negative. The additive inverse is something new that we kind of looked at just in that last little section. Okay, the additive inverse is something called this. It's the opposite number that, when added to the original number, results in a sum of 0. So we call these the additive inverse. When I add that to it, we call them 0 pairs. So let's say I had the number 4, and I am trying to think, okay, what is the additive inverse of 4? Well, I'm looking for the opposite number that when I add it to the original number, or when I add it to 4, I get a sum of 0. So basically, how can I add something to 4 and get to 0? Well, if we think of the opposite, right, the opposite of 4 is -4. So we would say that this is my original, right? 4 was what I started with, and -4 is the additive inverse of 4. Right? When I add it to 4, I get 0. Okay, these two together later on we're going to know as 0 pairs. Okay, or 0 pair. Two numbers that when added equal 0. Okay, I can also do that with a negative number starting. Right? If I start with -17, I want to add something to it to get to 0. That would be an additive inverse. Well, in this case, I need +17. -17 was my original, and +17 this time becomes my additive inverse. Okay, additive inverses are not always negative. Okay, they're not always positive. It just depends on where you start. All right, let's keep going. So you have this page. It says step 1, step 2, and then all these integer rules. I meant to take this out, actually. This is more for subtraction. We can go over it again, and I'll show you it does work for addition, but we're going to save this for subtraction. Skip over this part. What I do want to talk about this. Okay, how do we add and subtract integers on a number line? Well, it goes like this. My first step is to plot the first number on the line. I'm going to start with my first number wherever it is. Then, from that point, we're either going to move right or left the number of jumps indicated by the next number. Okay, we're going to move left when my next number is negative, and we're going to move right when my next number is positive. Again, this is for adding. Subtracting gets a little different. We'll talk about some strategies we can do there. But for adding, left is negative, right is positive. So let's take a look. If you remember our steps, step 1, right? Start at original. Start at original. Okay, my original number in this case is 4. So I'm actually going to start right here, just like that. Step 2 says go forward or move left or right based on the number of jumps of the second number. Well, my second number is -4, and I see negative, so I'm going to think go left. How many times? Well, I'm going to go 4 to the left. 1, 2, 3, 4. Okay, so my answer to 4 plus -4 is 0, which makes sense when we talk about our additive inverse, right? The additive inverse of 4 is -4, so we really should have expected to go back to 0 in that case. Okay, here's another example, -1 plus -3. This time I've got two negatives. First step, start at my first number. Start at -1 right there. Second step was to go left or right, the number of jumps as indicated by the second value. Well, this is negative, so I'm going to go left, meaning I'm going to go 1, 2, 3 more to the left. Where does that put me? I end up at -4. Okay, number lines are really nice. We can kind of use the jumping to model this out, and it's really nice for adding because all we have to remember is left is negative, right is positive. All right, last example here, -2 plus 6. First step, go to my first number, and then hop the total number of spaces as said by the second value. This time, this is +6, so we're going to go right 6. 1, 2, 3, 4, 5, 6. -2 plus 6 ends up being 4. All right, here's some try problems. Pause the video, try them out for yourself using the number line, and we'll talk about how can we not use the number line in the next set of examples. All right, looking at this, -2 plus 2. We're going to start at -2. My second number is positive, so we're going to go right. How many times? 1, 2. And we end up right back at 0, right? In this case, 2 would be the additive inverse of -2. 4 plus -5. First step, start at 4. Okay, then -5, negative meaning left. 1, 2, 3, 4, 5. We should end at -1. -3 plus -3, start at -3. And we're going to go left since my next number is negative. 1, 2, and we got to add in our answer of -6. All right, let's say you're like, okay, awesome. What happens if I don't have a number line or I don't want to use a number line? Okay, we can always think about it in this way as well. Okay, say you have two numbers that have the exact same sign. They're both positive or they're both negative. Okay, we can always kind of use the absolute values of them and then just add in the sign later. Okay, so here, right, both of these are positive. So I'm just going to think normally, what is 2 plus 5? Well, 2 plus 5 is 7. At the end, I'm just going to make sure that my sign matches what I started with. I started with two positive numbers. I'm going to end positive. Let's say I start with two negative numbers, right? In this case, I could be thinking to myself, okay, what's 2 plus 5? Well, 2 plus 5 is 7. Since both of these were negative, that means my answer is also going to be negative. Okay, we're just adding more and more negative on. Okay, so that's one way we can do it when they have the exact same sign. So for an example, -4 plus -2. Okay, I see that both of these are negative. I'm going to think in my head 4 plus 2. Well, that's 6. Okay, so I know that my answer has something to do with 6, but my two signs before were negative, meaning my answer is going to be negative, and I get a -6. Again, why? Well, because my two things that I started with had the same exact sign. They both were negative. Okay, here's some try problems for you to try out. Right, some of these might go really quickly. Some of them I want you to think about, and we'll keep going from there. So for our first one, 7 plus 13. 7 is positive, 13 is positive. I'm going to think, right, 7 plus 13, 13, 14, 15, 16, 17, 18, 19, 20. Okay, check my signs. I started with two positives. I got to end with positive, and we get to positive 20. For my next one, I'm going to think 8 plus 5. Right, 8 plus 5 is 13. So I know this has to do something with 13. This was negative. That was negative. Since they have the same sign, this is also going to end negative. Okay. For the last one, -2 plus -15. Well, 2 plus 15, that's going to equal 17. Okay, so I know that it has to do something with 17. Okay, however, this was negative, that one's negative, so I'm going to end negative as well. All right, what happens if I have different signs, okay, without a number line? This is one you got to make sure pay attention to. But again, it's not too difficult in nature. Okay, so for this time, what we're going to do is we're going to take the lesser value, and we're going to subtract it from the greater absolute value, aka looking at the numbers themselves, we're going to take the smaller of the two, subtract it from the bigger. Okay, we're then going to use whatever the bigger number sign was as our final answer sign. So here's what that looks like, right? If I think about these two, right, and I think about their values or their absolute values, well, the absolute value of 8 is 8, and the absolute value of -10 is 10. Okay, so I'm going to subtract the lesser absolute value, in this case 8, from the greater absolute value, which is 10, aka 10 minus 8. When we do 10 minus 8, we end up with a answer of 2. And so the last step of this is to use the sign of the integer with the greater absolute value. Well, we know that 10 is greater than 8. 10 had a negative sign to begin with, so my answer should be -2. Same thing over here, right? The absolute value of 13 is 13. Absolute value of 17 is 17. Okay, subtracting the small from the big, we get 4. My greater absolute value is 17. That one is positive, so my answer should be positive. All right, a couple more examples for you. right? We're going to start absolute value of 5 is 5. Absolute value of negative 10 is 10 away from 0, so that's 10. Subtract, since they have different signs, right? This is positive, this is negative. Always check that. We're going to go 10 minus 5, which is 5. And then we take the sign of the bigger absolute value. 10 is bigger than 5. 10 started off as negative. My answer should be negative 5. A couple more here. Negative 3 plus 7. Well, the absolute value of negative 3 is 3. The absolute value of 7 is 7. They have two different signs. So I'm going to go 7 minus 3, big minus small, which is 4. 7 is the greater absolute value. It was positive. This is going to stay a positive 4. Here, both of these have the exact same uh, absolute value, right? Negative 12 goes to 12, 12 goes to 12. So it doesn't matter what order I do it in. 12 minus 12 is 0. These are, okay, right? 12 is the additive inverse of negative 12. So it makes sense that this answer is 0. Here's some try it problems for you to do on your own. Try them out. Remember, if they have opposite signs, take the sign of the greater absolute value and go from there. All right, let's see. So I have negative 2. The absolute value of that is 2. Absolute value of 11 is 11. 11 minus 2, since these have opposite signs, is 9. 11 is the greater absolute value. It was positive. This is positive 9. Absolute value of 9 is 9. Absolute value of negative 10 is 10. These have two different signs. 10 minus 9 is 1. 10 is the greater absolute value. It was negative, so my answer is negative 1. Here, I just have additive inverses of each other, or a 0 pair, negative 31, positive 31. That's just going to result in 0. All right, here's a couple of things to think through. We'll do this in class as well, but just if you wanted to take a look at some of these questions and think, do these make sense? If not, why would they not? We'll discuss this more in class. All right, here is a word problem example in which it shows that a list of 4 account transactions. Find the change in account balance. Okay, so right, if we think about this, a withdrawal is when you take money out of the bank. Okay, so take money out. A deposit is when you put money into a bank. Okay, so my guess here is we should add up all the withdrawals together, all the deposits together, and then figure out what our balance is going to be. Okay, so let's see. I have a withdrawal right here and a withdrawal right here. I have negative 40 and negative 50, right? I'm adding my two withdrawals together. Since they have the same sign, I can just think about adding them like normal. 40 plus 50 is 90. Since both of these are negative, my answer is going to be negative. So my total withdrawals, meaning my total, the amount I took out, is $90. My deposits are 50 and 75. 75 and 50. Okay, both of these are positive, so I should have a positive answer. It's 125. Now from here, I have negative 90 and 125 being added together as my final thing, meaning I put $125 in, but I took out $90. This is positive, this is negative, so I'm going to have one of those cases where I subtract and take the bigger absolute value, right? 125 is the bigger absolute value in this case. We're going to subtract it away from 90. This leaves me with 5. Got to borrow there, 35. Since 120 is the bigger number, we're going to take that sign, meaning my account balance is a positive $35. All right, here's something that works with times, right? We can make a little table for this one. Okay, so we're going to say, hey, starting at 12 o'clock, okay, this is time. and we have water pressure. Okay, the water pressure starts at 435. Okay, from 12 to 12:30, we can see that the water pressure increases. So we're going to put a plus sign by 58 pounds per square inch. From 12:30 to 1 p.m., the water pressure decreases. So decreases would be decrease or subtract by 116 pounds. What is the water pressure at 1 o'clock p.m.? Okay, so yes, these are my times, but I'm signifying what happens in between each of these times, right? From 12:30 to 1 o'clock, we go down that much. From 12 to 12:30, we go up that much. So really what we're doing is this: 435 plus 58 plus negative 116. All right. To make this maybe a little bit easier on ourselves, we can kind of combine our two positive values right away, right? They both are positive. That's going to end positive. 435 plus 58 is going to end up being, well, that's 13. 1 plus 3 is 4, plus 5 is 9. And I get 4. So this is going to change to 493 plus negative 116. This is a positive value. This is a negative value. Okay, we're going to subtract the smallest absolute value from the greatest absolute value. In this case, this is the greater one. This is the smaller one. So 493 minus 116. We end up with, this is going to need to borrow from here. 13 minus 6 is 7. 8 minus 1 is 7. 4 minus 1 is 3. Okay, we take the sign of the greater absolute value. It's positive, meaning my water pressure at 1 p.m. So at 1 p.m., my water pressure is 377 pounds per square inch. And just like that, we have our answer. All right, last of it. This is a try problem for you to try on your own. Okay, it looks like we've got a mountain situation here, and I want us to think about, okay, what do we need to do in order to solve this? Okay, some key information that we have is that we start an elevation of 8,136 feet, and then it's asking what is the end of the trail elevation. So give it a try, and we'll go through it in a second. All right. So if we start at 1,836, that'll be right here. Okay, that is 8,136 feet. It says we go down to here, so we go down 174 feet. So we're going to add minus 174. It then says from here to all the way up here, we're going to add 350 feet. Okay, from the next point down, we go down 180, so add negative 180. And then finally, our final ascent, we're going to add 282 to this. All right, so let's see. I'm going to add all my positive numbers together, and then I'm going to add all my negatives together to get one positive and one negative number. So for all my positives, I have 8,136, 350, and 282 that we're going to add together. 6 plus 0 plus 2 is 8. 3 plus 5 is 8, plus 8 is 16. 1 plus 1 is 2, plus 3. 5 plus 2 is 7. And I drop down an 8. So all of my positive values together is 8768. And then for my negatives, I have 174, 180. We're going to add those two together since they are both negative. Right, we add them together and then just take that sign. And we got 4. 7 plus 8 is 15. And then 3. All right, and again, this one is going to be negative since both of our elevations there were negative. So for a final, I have 8,768 plus a negative 354 feet. This is positive, this is negative, meaning we've got to subtract them. Take the bigger one, subtract the smaller absolute value. So 8,768 minus 354. Well, 8 minus 4 is going to be 4. 6 minus 5 is 1. 7 minus 3 is 4. And I get 8 as well. All right, so what is the elevation at the end of the trail? We would say it is 8,114 feet.